Okay, we're in section 17 and we're doing the homework. My recommendation is to get the structure of the notes down. And what I mean that it might be a good idea to have the notes in front of you as doing homework. And what are you doing? You're studying. What are you studying? You're studying the convergence of a positive series. All right. So when I say positive, I should say a series with positive terms in it. So we're going to do homework. And again, as I do the homework, I'll read the question to you. As I write work down, it's going to be chicken scratch, but there is typed up work for you to look at if you prefer to look at the type up work. So let me do another share with you and just give me 1 second to do so. And let's take a look. I'm going to share my whiteboard with you. It's warming up now as we speak. So reading this over here, it says, use the integral test to determine whether the infinite series is convergent. Well, the first thing is I'm going to write down AN for you. So what's AN? Whoops, I got to put my pen out. So AN of this, and again, we're looking at this over here, is equal to 7 over n squared plus 1. Well, looking at it, this is certainly, we're starting at 1, by the way. This is certainly a positive. All right, no matter what number I choose, n, and again, the interval is going to be 1 to infinity. All right. So what I'm saying, 1 to infinity, 1, 2, 3, 4, 5. Yeah, it's definitely positive. There's no doubt about that. And it's also decreasing. All right. So the integral test is certainly appropriate here. So I'll write the integral down for you. What's the integral? Oh, I got to write f of x down. Well, the analogous continuous function would be 7 over x squared plus 1. All right, let's write this down. So it's going to be 1 to infinity, 7 over x squared plus 1. And again, I'm looking to do the integration. And again, I'm getting a little better just from practice. Again, a year from now, if I'm not practicing, I'll get weaker at this. But this will be a limit problem. And it's going to be 7 times the limit as r goes to infinity, integration 1 to r. And this will be 1 over x squared plus 1 dx. Well, that's something I can remember from math 121. I remember the antiderivative of 1 over x squared plus 1. So it's 7 times the limit as r goes to infinity. This is an improper integral. And this would be the arctangent of x. Limits of integration would be 1 to r. I'll write this down for you. This will be 7 limit r goes to infinity. Arc tangent of r minus the arctangent of 1. Now here comes a big problem. Can I do that limit? Of course I can. I mean, as I go towards infinity, for the argument r of arctangent, that would go towards pi over 2. We have a key, we'll check it later. And the arctangent of 1 is pretty simple. It's pi over 4. So it's going to give me 7, and this would be pi over 4. So the answer is 7 pi over 4. Now, a lot of students lose track of what the question was. That was not the question. The question was, says use the integral test. And this is a finite number. So what do I know? By the integral test, I now know that this sum, n equals 1 to infinity, that's a 7, right? 7 over n squared plus 1 is convergent. I mean, I don't know what the sum is, but I know it's convergent. Again, I want you to look over here and look at the work. And this would be the work that's written down over here. All right, let's go to the next one. That one's done, not that bad. I put my work down and I feel good about it. Again, it's typed up for a reason, by the way, and you should be aiming for a typed up work as well. All right, so let's take a look. Next one's also an integral test. I'll write this down for you. And this is going to be the sum, n equals 1 to infinity. And you're going to get 4 n squared plus n. So I'm going to write an down for you. What's an? It's 4 over n squared plus n. And this is definitely positive decreasing. And when I say that, positive decreasing for 1 forward, I don't have to worry about anything else at this point. So I'm going to write f of x down. f of x, the analogous function would be 4 over x squared plus x. So we're going to use the integral test. And before I do that, I'm realizing that this is probably a partial fraction problem. I'll put this over here, partial fraction we covered in the past, and you're going to continue to use that into the future. And let's see what that would give you. Let's see, x, I'll put an a there, and I'll put a b over x plus 1. I'm getting a little better at this too. It's going to be 4a x plus 1 plus bx. I would probably pick x to be 0 because it's easy to do. And what would you get? A is 4 then. And then I would probably pick x to be minus 1. And what would that give me? B would be minus 4 then. All right, let me write this down for you. What are you going to get over here? Well, 4 over x minus 4 over x plus 1. By the way, when you're doing homework, I want to recommend, it's not like taking an exam, but when you're doing homework, I would definitely look at the key one step at a time, and partial fractions 4 over x. Good, I got that covered. Okay, now next thing what I want to do is I'm going to do an integration, and the integration is going to be of f of x. So I'm using the integral test, and that's going to be 1 to infinity. And what's that going to be? 4 over x minus 4 over x plus 1 dx. This is an improper integral. I'm going to write down a limit now. This is 4 times the limit as r goes off to infinity. 1 to r, 1 over x minus 1 over x plus 1 dx. All right, again, I'm doing work. You need to do work on exams to support your answers. You can't just simply say, oh, yeah, it works, and that's good enough for me. So it's going to be 4. Well, this one doesn't look too bad. It's limit as r goes to infinity. Well, this is going to be the natural log absolute value of x minus the natural log of the absolute value x plus 1. Well, I'm going to write that down now for you. It's 4 limit r goes to infinity. And what would you get over there? Well, I'm going to do this over here. It's the natural log. Let's put this down. And by the way, the x's are positive. It's between 1 and infinity, and x plus 1 is certainly positive. So I'm just going to write this over here, x over x plus 1. And I want to see if I can do that. Ooh, I forgot to do the limit. Sorry about that. 1 to r. Sorry about that. So 1 to r. No, I forgot to put that in there. And I'm glad I caught that. So let's put this down 4. Well, let's put this down limit r goes to infinity. Well, this is going to be the natural log of r over r plus 1 minus the natural log of 1 over 2. Let me see if I did that right. Upper minus lower. Yeah, I think I did it right. Let's keep going. And I think I can do it without too much work. The first guy's limit, I'm looking at, it's a natural log, and the argument's going to be positive. And if I divide top line by r, I'd get the natural log. Let's put this down 4. I get the natural log. What do I get the natural log of? It'd be 1 over 1. So natural log of 1, that's 0, right? And this is going to be minus the natural log of 1/2. Again, I must say I'm a stickler for detail, but I want to continue to write this down. So what are you going to get over here? 4, well, 0, 0. So it's 4 times the natural log, that's minus, right? 2 to the minus 1. As soon as why are you doing that? I'm just going through the work. So it's going to be 4 natural log of 2, which is going to be natural log of 2 to the 4th power, which is 16. All right. Oops. I got so excited. I shouldn't have done that. This is a finite number. That's good news. So what do I know by the integral test? What do I know? And I'm using the integral test. I now know that the sum n equals 1 to infinity of, I just got to remind myself what it is. It's 4 over n squared plus n is convergent. I now know that by the integral test. All right, let's look at the work. And again, we're trying to encourage you to look at the work as well. And certainly I'm seeing my answer over there and I feel good about it. Not that I'm detailed looking at my work, but if you have any questions about what's written down, whether I'm writing it at the board in my chicken scratch or I'm typing it up, please feel free to ask questions. I do mean that. Please feel free to ask questions. All right, let's do number 3. Number 3 is a little more difficult for me because it's a natural log problem, but I'm looking at it and I want to write down, I'm going to use the integral test. You know what? I'm just going to go to the next page so I can have to see the key next to it. So I'll put this over here, and this is the sum, n equals 3. That's a weird number to start at, and infinity. And someone says, I wonder why they're starting at 3. They could have started at 1, for example. They couldn't have started at 0, by the way. And I think the reason they're starting at 3 is they want to make sure that this is going to be a positive term series. All right. Now, I'll be honest with you. You may be confused by this, but I hope you realize that n squared grows much faster than n squared. All right, 3 forward. So I'm going to say this is an is 7 ln n over n squared. It's positive term. It's positive. All right, and it's decreasing. So what I'm going to do is I'm going to try to integrate now. So I'll put my function down. This is a continuous function now, and that's going to be 7 natural log of x over x squared. Now, granted, my gut feeling is they're not going to give you something you can't do. It would be awful to give you a problem you can't do. Let's take a look. So what do you get over here? Now we're not starting at 3. So this is, I'm sorry, we're not starting at 1. We're starting at 3 now, and we're going off to infinity. And I'm going to maybe write 7 here, and then ln x over here, and then x squared dx over here. And I realize I got some troubles immediately. And I'll tell you what the troubles are. I have to integrate this guy, and I'm not looking at it. It's not something I recognize. So I got to play around with it. So I'm just going to do some side work over here, side work. And I'll look at it. And I'm looking at ln x over x squared dx. All right. And certainly, if someone says, what are you going to try? Not that I always try the success thing, but you got to get busy trying. So I'm going to try, I don't know, maybe integration by parts. So I'm going to say u equals the natural log of x, and du would be 1 over x dx. And then I'm going to say 1 over x squared dx equals dv. Don't be discouraged if things don't work, by the way. And I really do mean that. If they don't work, they don't work. What are you going to get over here? Well, remember, it's x to the minus 2. So I have to increase it. So it would be minus 1 over x. All right, let me see if I can do that. So uv, so minus natural log of x over, let's see, x. Let's say that uv, okay, I did that. Minus v, that's 1 over x. And then du would be 1 over x dx. All right, I'm going to keep doing this. And what do you get over here? Minus the natural log of x over x plus, this would be x to the minus 2 dx. Let me write this down now. Minus natural log of x over x. Well, I increased it by 1. So what do you get over there? Minus x to the minus 1, or 1 over x. Let me write that down. I fudged the, so minus 1 over x. And by the way, I know it's a constant integration. I'll put that in there now. But here's the problem. I'm wondering if that's true. All right. So someone should say, would you, before going forward to verify this, well, you know what? If I got an answer key, I would look at the answer key. But from the exam, what I would do is I would want to know if this is really true. And so what am I saying? Minus natural log of x plus 1 over x plus c. Is that really the antiderivative? Well, I'm going to check it. And I'm going to take its derivative. And I'm going to check. I'm going to check to see if this is right. I know this takes time for students, by the way. Take the time now, and it's going to pay off in the future. X, what's derivative of the top? Well, that'll be 1 over x, right? Minus the top, which is ln x plus 1, derivative of the bottom, which is 1. And what do you get over there? Minus, this would give me x squared in the bottom. And you would get, let's see, that would be 1 minus 1 minus ln x. Wow, miracle, it worked. So I'm going to say, gee, bingo, we got something there. Let me just erase my checking, and no one needs to see you check yourself, but I got the antiderivative, and I'm seeing it right over here. All right, so let's go back. I got my antiderivative, and I'm going to go back over here, and I'm going to write this down now. I'm going to start doing my work now. And what's this going to be? 7 limit as r goes to infinity. The integration is going to be 3 to r now. And that's going to be ln x over x squared dx. All right, let's keep moving. It's going to be 7 limit r goes to infinity. And let's see, I got that antiderivative, right? What's it going to be? Well, it's going to be minus ln x plus 1 over x, and we get a limit. The limits on this thing is going to be 3 to r. And I got to keep doing this, and it seems like work to you. Yeah, writing is work. Just imagine typing this up was what that would be like. And again, you should learn to type. All right, limit r goes to infinity. I got to plug this in now. So it's going to be minus, upper limit is minus ln r plus 1 over r. Minus of minus is plus ln 3 plus 1 over, let me put parentheses on that so you don't confuse it, over 3. Now, what do I know about this? Certainly the first guy over here, this guy's limit, the bottom grows so much faster than the top, would be 0. So that's pretty simple. Now, what do we get over here? We would get 7 times the natural log of 3 plus 1 over 3. So I'm not going to box that, by the way, but this is a finite number. So what do I know? And certainly I want to go back and check it. Did they get the same answer? Yeah, they did. All right, I'm seeing it over here. Now, someone says, well, you're really not looking at all the work they put down there. Well, when I'm doing homework, I'm not looking at all the work. I'm looking to see, do I get this thing right? All right. But I noticed they wrote some interesting things up here. And I guess I went through this, making sure it's, decreasing. All right. But anyway, I maybe did a little extra work over there. What do I now know? I know the series converges by the integral test. All right. Now let's do this one over here. This one says use a comparison test. Now, someone's going to say, I don't even remember the comparison test. Well, what you do is you look back at your notes, and I'm looking back at my notes too to make sure it's been written down for you. And they do talk about a comparison test. And so if I'm looking at a comparison test, I'm looking for something, and I got a rough idea looking at a comparison over here that I'm looking for a comparison. All right. So I'm looking for a comparison to this series over here, and either I want to show something that's above it or below it. And so what I'm going to do is, kind of looking at it, man, maybe I should think about this. So 1 over, and I'll look at the work later. All right. And I'm going to compare that to something else. I'm going to compare that to 1 over 7 to the n. All right, this is why would you do that one? Well, I know something about that one. I know something about it. All right, what do I know about it? I know that series would be a convergent series. All right, I know it. I know it. Now, someone says, how do you know that? It's geometric. It's a really simple series. Now, my question over here is that I know that this series here, I'll write this down for you. The series, n equals 2 to infinity, 1 over 7 to the n is convergent. I know it. I know it. I mean, I could get it some. I know it's some. Then the question comes is, how's the other guy compared to it? By the way, I want it to be smaller than it. Because if this converges to some finite number, I want this one to be smaller than it. Then the question is it smaller than it? And it is. And why do I know that? Well, I'm dealing with positive ends. This has got to be smaller. The bottom is smaller. So I'm going to say it's less than or equal to. Now, someone said, why would you say that? At 1, it's actually equal to it. But once I get above 1, it's going to be greater than it. So what do I now know? I know by comparison. I know this is a convergent. Let me write this down over here. This is convergent geometric series. What do I now know? I know this is also going to be a convergent geometric series. Let me write this one down. N equals 2 to infinity. 1 over n, 7n is also convergent. How's it convergent? I'm using the comparison test. Well, let's look at their work. Their work's a little different than mine, but it's really the same work and intent, written a little bit differently. Let's look at their conclusion. Since this is a convergent geometric series, we did state that this is also convergent. I feel pretty good about it. All right. Now this one over here, I'd be honest with you, these can be nightmarish. You know, what I mean by nightmarish, they're saying use a comparison test. I'm kind of looking at it and I'm wondering, does it compare nicely with something? And this one compares nicely with the P series, right? I think it does anyway. So what I'm going to write down over here, I'm going to say, I think it compares nicely to the P series n over 4. As I do that though, I want to write down why I think it compares to that. So the question becomes is, this is a convergent, whoops, I'm really bad in the penmanship department, aren't I? Convergent P series. Let me write that down. N equals 3. I'm using narrows to infinity. 1 over n4 is convergent P series. All right, I know that much. All right. Now the question is, what's the comparison now? And I want to make sure you understand something. Is that it's not at the bottom of comparing. I hope you can agree that sine squared n is always going to be less than or equal to 1. Always. It's never going to exceed 1. There's nothing I can do that to make it exceed 1. So this is true. So what do I now know? By comparison, by using the comparison test, what do I know? I know this series converges. N equals 3 to infinity, sine squared n over n4 also converges. I know that. All right, let's take a look at it. Again, I'm doing homework. This is all written up for you. And again, when your exams, you would have to state that. But I just want to go through it. Did they do this part here? Yeah. Did they talk about this thing being a convergent P series? Yeah. Did they talk about the comparison test? Yeah, I got that circled. What do I know about this guy over here? Also converges by the comparison test. All right, let's do number. Oh, this is an interesting one. So I want to point out, looking at this thing over here is, I wonder what they want me to do, but I don't like that negative power. So I'll write this one over here. I'll go to the next page later. This is a very simple problem, by the way. This can be 5 quarters to the n, which is definitely a geometric series. Now, where were we in geometric series? In Math 120. And what do they tell you about these infinite guys only converge if the common ratio, the R, is less than 1? Well, what's the R over here? When I say the R, it's a common ratio. What is it? It's 5 quarters. 5 quarters is greater than 1. So this is a divergent series. It's greater than 1. Remember, when you took a Math 120, and again, we reviewed it in 122 as well, it looked like this over here, where you had, A times R to the N, where N started maybe at 0 to infinity. And this could only converge if the R, whoops, I didn't mean to put the R down like that. If the R was this, what does that mean? The R is a proper fraction between 1 and minus 1. So what do I know about this thing over here? It's a divergent geometric series. Let's go to the next page. Again, we're doing homework. What does it say divergent? Why is that? The R 5 quarters is greater than 1. And again, stated over here. All right, this one says use a limit comparison test. And again, what I'm claiming over here is that I'm hoping you guys have notes in front of you as you're studying these problems over here. Now, someone's going to say, on the exams, will I have notes in front of me? No, but you're studying now. You're not taking an exam, you're studying. So what is this one over here? It says, use a limit comparison test. So I'm kind of looking at it and I'm wondering, what would I compare this thing to? Okay. So I'm looking at it and I'm going to say, maybe I would compare it to something like this. N compares nicely with N, right? Now the bottom, I would say, what would that be? It would be N to the 7/2, right? And what does this equal? By the way, they're not saying use a comparison test. They're saying use a limit comparison test. They did not say use a comparison test. They said use the limit comparison test. All right, make sure you know the difference between the two. Now, what would this one reduce to? 1 over N. Let's see, I have to do some arithmetic there, right? That's 5/2, isn't it? This is a convergent P series. All right, convergent P series. So what do I have to do? I got to do the limit comparison test. So take a look at it. Limit as N goes to infinity. And then I got to take the ratios of that. All right, now, by the way, these are positive term series problems over here. And I'm going to tell you, that they're both positive term series. I'm just going to take the ratio of the two. Let's write that down. I know it's tough, by the way. So the top one, I'm going to write down, I'm going to make this the top, all right? And that's going to be N over the square root N7 plus 1. And the bottom is 1 over, I'm going to write a square root problem, by the way, the square root of N to the 5th power. And this looks pretty nasty, doesn't it? I got to do some work over here. So limit as N goes to infinity. I'm going to write the top thing as a square root 2. I'm going to write the square root of N squared. And that's going to be square root N7 plus 1. Now I'm dividing by that number. So that's like multiplying by its reciprocal. So N to the 5th over 1. And I think I can do that. Let's put that down. Limit N goes to infinity. Well, I get something pretty interesting here, don't I? I get this. N7 plus 1. And it's certainly, the inside, I kind of like looking at the limit of it, it's pretty simple. What do you get over there? Well, it's going to be the square root. I'm taking the limit now. 1 over 1. Yeah, 1 over 1, which is 1. I'm dividing by N7, by the way. That's 1. So here's the problem then, is you have to interpret this over here. This is a finite number greater than 0. Well, that's clear as day. So what do I now know? Well, with this is a convergent P series, by using the limit comparison test, I now know that this thing also converges. What I use the limit comparison test. I want to point out all the work is written up over here with the conclusion. What's the conclusion? I found the limit was 1, it's greater than 0, it's a finite number. I conclude by the limit comparison test that the series converges. Now, granted, we type up the limit comparison test for you. We would like you to read through that and, think about it. I mean, sometimes it's tough to think through this stuff. And I'm not going to say you can remember what you've read, but maybe you're going to retain something about the limit comparison test. It's easy to forget this stuff too. I know that. Let me go to number 8. Number 8 is another thing. It says determine if the series converges or diverges n equals 1. All right, I got to look at it. And then my first was, is it a positive term series? And looking at it, I'm thinking about it now. The cosine would never exceed 1. So I'm thinking about the first term, by the way, cosine of 1. Well, cosine of 1 is definitely less than 1. So it's definitely positive now. I know this is a positive term. Is it decreasing? It sure is. The bottom growing much faster. So it's also decreasing. I could use the integral test, but I'll be honest with you, I don't know if I want to use the integral test in that. I think it might be way too difficult for me to even consider it. So what I'd like to do is I'd like to use a limit comparison test. So what I'm going to do is write down on the side, and again, I'm using the limit comparison test. So I'm going to write on the side n squared minus cosine n over n4 might compare nicely to n squared over n4. And someone says, what about the cosine? It's just making my life too difficult. So I'm going to say this compares nicely to 1 over n squared. Now, what do I know about this guy over here? This would be a convergent P series. Where are they starting? Starting at 1. This is convergent P series. By the way, I'm not saying it's going to work for me, but I am not putting an inequality over here. I'm not doing that. All I'm saying is this. I just want to use the limit comparison test. So what I'm going to do over here, I'm using the limit comparison test. I'm going to look at this. The limit as n goes to infinity, I'm taking this to be the top. This would be n squared minus cosine n over n4. I'm going to take this to be the bottom, 1 over n squared. I have to rewrite this guy because I really can't do that as written. And what would this be? Let's write this down. Limit n goes to infinity. Again, I want to do the work. This is n squared minus cosine n over n4. I'm dividing by the bottom, which is like multiplying by its reciprocal, which would be n squared over 1. I'm going to keep doing this until I can get that limit. And what would that give you? N squared minus cosine n over n squared. Oh boy, I think I can do that. What's this guy give me? Limit n goes to infinity. That will be 1 minus cosine n over n squared. Well, that's a fairly simple limit. And the reason being is that second term goes towards 0. What do you get over here? 1. Is 1 a finite number greater than 0? Of course it is. What do I now know? I know the series, original series over here converges by using the limit comparison test. So again, I want to point out, if I were doing homework, I would say, oh yeah, they use limit comparison test. They wrote down pretty much what I wrote down. They did the limit. They said that this series converges by the limit comparison test. All right. All right. Let's just do this one now. And it looks pretty tough. All right. So I'm going to look at it. And I want to use a limit comparison test on it. So what am I doing? I'm looking at it. And I'm going to pull a 2 out from this, just to make it easier on me, by the way. You know what? I won't pull a 2. I'll just leave it as is. So 2n plus 2 over n minus 1, n minus 2. And I'm going to say, what do it kind of compare to? I don't know. Maybe I'll say it compares nicely to n, sort of on top n, right? And at bottom, I'm going to say n, which is n cubed. So I'm going to say maybe it compares nicely to a P series. I'm going to put this over here. So let's write that down. N equals 1 to infinity, 1 over n squared is a convergent P series. Again, we'll look at the key later. So what am I going to do? I'm limit comparison test, right? Even say it. Let's do it. Limit n goes to infinity. I'm getting a little better at this now. So I'll put this down. 2n plus 2, n minus 1, n minus 2. And what are we going to do? Well, we're dividing by 1 over n squared. That's like multiplying by its reciprocal, which would be n squared over 1. I think I can do that. I'll write this down for you. And this is going to be n goes to infinity. And what do you get on top? 2n cubed plus 2n squared, and at bottom you get n minus 1, n minus 2. Well, I'll be honest with you, this is a little more difficult for me to do, but I'm going to do what I did in Math 119, which is divide by the highest degree variable, and that's a cubed. So I would get 2 plus 2 over n, and I'm dividing the bottom by n cubed. So there's actually 3 factors of n. So it'd be 1 minus 1 over n, and then it would be 1 minus 2 over n. That might seem strange to you. Limit of the top is 2. The limit of the bottom is 1. 2. Is 2 a finite positive number? Of course it is. So what do I know about this thing over here? It's also convergent. What test did I use? Limit comparison test. Let's just look at the key. That's number 9. Let's see how they did. And I think I did sort of like this over here. And yeah, I got 2. And yeah, I did that. All right. Oh boy, 10 doesn't look easy. Determine the convergence or divergence of that thing over there. Let's see. I got to write this down now. So it's going to be sum. I don't lose track of things. N equals 2 to infinity. And ln n. All right, let's take a look and see if we can handle it. By the way, certainly I would love to do integration on it, but integration is something that might be really tough for me to do. And I'm going to say comparisons might be appropriate here. All right, comparisons may be appropriate. Limit comparison test, whatever. Let's take a look. And if I'm at 2, let me think for a second. Push them aside. Well, the natural log of v, I'm just going to put this over here, looks like this, right? My question is, where does it become 0? Right, so the natural log of n equals 0 when you are at 1, right? Well, that's good. So I'm at 2, that's pretty good. So I know this is a positive term. Let me get my eraser out. I'm feeling pretty good about that. Positive term. And what else do I know about it? I know the bottom's growing. I mean, look at it. Both those numbers are getting bigger and bigger and bigger as we get bigger, right? Like 2 to 3 to 4 to 5. So it's positive. Whoops. And decreasing. So I guess I could use I don't want to use integration, by the way. Looks too difficult for me. I'm not saying it's not doable. I just don't want to do it. So I'm going to look for a comparison. And I'm going to go for P series. I'm going to write this down now. Again, I have an option now. I could use limit comparison, or I could use comparison. I'm looking at this thing and I'm wondering what I want to do. Well, 6/5 is bigger than 1, right? So this is convergent P series. I want to look at this. I'm going to kill this off pretty quickly. And I'm not looking at that. I hope you agree that the tops are definitely in comparison. 1 is 1. And look at the bottom. What do I know about this thing? I got to think now. I hate to say it, I got to think. Well, this one here is going to be bigger than the one below it. How do I know that? Well, the natural log of n makes the bottom even bigger. So it's going to be smaller than that guy. So I'm going to say by comparison test, not limit comparison. You could do limit comparison. What do I know? I know this series converges. All right, let's look at the key, see what they got. And again, my work in the key might look different than over here, but I did write this down. By the way, the equality is not held anywhere, not from 2 above anyway. But this series over here converges. Let's go to the next page, see if they said that. Convergent P series. So by the comparison test, this one. You could have also used limit comparison test. All right, let's look at number 11. And number 11, another I'm gonna say another question that I got to think about it. And I hate to say thinking is required, but I'm thinking, and thinking does require me to do something over here. And I really have to think about this thing. So AN, and that's 6 to the n, 7 to the n, minus 2 to the n. Now, I have to think, and I'm starting at 1. So my thinking of this over here is, I would just like to write down A1. I'm going to erase this later, by the way. That's going to be 6, and 7 minus 2 is 5. Let me write down A2. Well, A2 is going to be 36, 49, minus 4. So that's going to be 36, right? You get the idea what I'm doing? 45. So I'm starting to realize, certainly it's positive term. Let's just go to the next guy. If you did the next guy, what would you get? That's 6 cubed. I'm not going to do it. And this would be 7 to, I'm sorry, I'm going too quick here. 7 cubed minus 6. It's definitely positive term. So I'm going to erase that business there. Whoops, sorry about that. I know it's positive, but I did it again, didn't I? I know it's positive term. That's what it says. Did you really need to go through that? That's positive term. Maybe not, but you know what? You get tired, you start to have to think. It's positive. The next thing I wondered, is it decreasing? And I want to write down what I'm saying over here. If it's decreasing, and I got to think, I'm getting tired. It's like, it's the 11th problem. I have to think. So I'm wondering, is 6n over 7n minus 2n, what's the next term going to be? 6n plus 1. That would be 7n plus 1 minus 2 times n plus 1. And what am I hoping? I'm hoping that this guy is bigger than that guy. I'm hoping for it. Let's see if we get this. So I'm going to divide both sides by 6n. You would get 1. This is 7n minus 2n greater than 6. This would be 7n plus 1 minus 2n minus 2. Whoops, sorry about that. I think you get the idea what I'm doing, right? So this would be 7n plus 1 minus 2n minus 2 greater than 6 times 7n minus 12n, right? Oh, let's see what we get over here. Well, this is going to be 7. I have to think, right? Where's part of I think you get stuck sometimes, And I think I'm going to get this thing on one side. And what's that going to be? Well, that would be 7n now, right? I cross that out, indicating that's done. And then when you get over there, I'm going to just get everything onto one side. Now I have to put the other stuff on the other side. What's it going to be? 2 minus 10n. Well, I hope you can agree this holds. This is definitely true. Again, the 11th problem, I'm struggling, right? So let's get my eraser out. And this could happen to you when you're doing homework. You can get tired. I know this is true. So I know now that this is not only a positive term series, I know it's decreasing. And again, I had to lay my fears. Getting tired, allayed my fears. So it's decreasing. I know that much. So now I can use all those kind of neat things I have over here. So I'm going to use I guess I'd use a comparison test over here. And what's a good comparison? I'm going to look at that and say, do I know anything that compares nicely to that? And let me call it BN. I'm going to say it looks like 6N might compare to that top. And the bottom, I'm going to say really the most powerful guy in the bottom, 7N. And what's BN? That would actually be 6/7 to the n. I got to remind me what the limit's going to be 1, right? So I'm going to write this over here. Limit n equals 1 to infinity, 6/7 to the n. And what do I know about this over here? It's a convergent geometric series. So I'm going to use the limit comparison test. And if it doesn't go, it doesn't go. All right, let's take a look. Limit as n goes to infinity, 6n, 7n minus 2n. I'm getting better. So I'm dividing by that 6n over 7n, which is like multiplying by 7n over 6n. Yeah, I think I did it right there. Equals limit n goes to infinity. We'll look at the key later. The top would be 7n. I want to put out what I mean by these things are canceling off here. It's good news for me. 7n minus 2 to the n. I'm going to divide through by 7 to the n. Limit n goes to infinity. 1 minus 2n over 7 to the n. What does this give me? 1. Pretty simple limit, by the way. That 7n grows super, super fast. What do you get over here? Definitely greater than, it's a finite number greater than 0. What do I now know? I know by the limit comparison test that this series over here converges. Let's just take a look at the work. I'm seeing the work over here. I got the same limit. And we did say by limit comparison test that the series does converge. You should read through that. All right. Let's look at number 12. Number 12 looks like a nightmare. I don't know what they want me to do. Oh, I guess they want to see if the terms are converges. I don't know. Maybe I can do it. So I don't know. Let's just be careful about it. And I'm looking at it. And it definitely, looking at it, the bottom grows really fast. It's a 4-degree polynomial. So I'm going to say it's definitely decreasing. At some point, it's decreasing. All right. Now, the question is it a positive term? Looking at it, and if I did 1, right? If I start at 1, what would I get? 5 minus 5 minus 17. That's negative. That's not good. So I can't start at 1. Let's start at 2. All right. What do you get over there? You get 5 times 2 to the 4th power. It's 2 times 2 is 4, age 16, right? Minus 5 times 4 minus 17. And what would that give you? Let's take a look. That gives you 50 and 30, 80 minus 20 minus, I can do this now. So I'm going to write this down. And I'm going to say, you're really killing me with this. N equals 1 to infinity, 3n squared plus 15n, 5n 4 minus 5n squared minus 17 is identical to, well, if I started at 2, I'm going to put this down over here instead. N equals 2 to infinity, 3n squared plus 15n, and the bottom would be 5n 4 minus 5n squared minus 17. All right, so that's positive term series there. Let me erase my chicken scratch on the side, though. It's kind of annoying me to see it there. I got to write the first term down now. I know, it's crazy. What's that going to be? 3 plus 15, which is 18. The bottom would be 5 minus 5 minus 17. You get 18 over minus 17. So minus 18 17ths plus this. Now someone's going to say, is that really necessary? I don't think so, but I like to put it down. So let's put this over here. Let's look for something to look for. What am I going to do? Well, I'm gonna look for a nice comparison. All right, so I'm gonna say, I'll look for a nice comparison. And let me look for a comparison here. And the comparison I want to look for, let's take a look. I'm going to say a good one would be, another series would be this. Whoops, didn't mean to do that. This series maybe. 3n squared. That's the biggest guy on top, by the way. And 5n4, where n starts at 2 and goes to infinity. Well, I'm going to factor out the 3/5. And what do you get over there? N equals 2 to infinity. And that would be 1 over n squared. Now, what do I know about this over here? Convergent P series. We'll look at the key later. So what I'm going to do, I'm going to use limit comparison test, LCT. And write this down, limit, as n goes to infinity, 3n squared plus 15n, 5n4 minus 5n squared minus 17. I'm going to take this guy and I'm dividing by it. So what I'm going to do is multiply by its reciprocal. And what's that going to be? 5n4 over 3n squared. Limit. This could get nasty. Okay, let's do the multiplication. That's going to be 15n6 plus 75n5. Oh, that's nasty. 15n6 minus 15n4 minus, well, what's 3 times 17? 30 and 21, 51n squared. And I think I'm ready to do the limit. If you divide through the highest degree variable, I hope you realize you'd get, the leading thing would be 15 over 15, which is 1. Is that greater than 0? Of course it is. What do I now know? I know that this series converges. What does it say? This one converges. All right. All right. So relate to one above it. It's equal to it, actually, with this number when you add on to it, minus 18. Let's look at the key, though. I don't know if they went into that detail. I don't know. I got to look at it. And over here, I want to put out, yeah, they didn't bother with that bottom thing. It really doesn't much matter. At some point, it becomes positive decreasing. But anyway, this is okay. All right. We did okay. All right. Here's the deal. If you got questions, right? If you're studying hard and you got questions, try to get your questions resolved. How do you do that? Come by during office hours. Here's the deal, though. You have to work. You have to put the study time in, and that takes time and effort. Thank you for your attention. And again, good luck.